Section 1. Your computer's filing cabinet, brought to you by U.S. Computer Support. A file system is the method your computer uses to organize and store data on a drive. Think of it as a massive digital filing cabinet. How to label folders, where to put documents, who's allowed to open which drawers. Without this organized system, your computer couldn't find the programs you want to run or the documents you have saved. Understanding this system is the first step to mastering security and organization. Especially important in Linux, where everything is treated as a file. Permissions are like keys and locks on that filing cabinet. They determine who can look at a file, who can change it, and who can run it as a program. Section 2. The building blocks, file systems, files, and folders. Linux is flexible and can work with many different kinds of file systems. The most common one you will find on a modern Linux system is called ext4. It is known for being reliable, fast, and secure. You might also encounter VFAT, often used for USB drives and memory cards. It's compatible with almost every operating system, including Windows and Mac OS. If you are working with a drive that comes from a Windows computer, it will likely use the ntfs file system, and Linux can read and write to these as well. Before you can access the files on any storage device, like a hard drive or a USB stick, you must first mount its file system. Mounting is the process of telling the operating system to make the contents of that device available in a specific folder. Here's how that looks. For example, when you plug in a USB drive, Linux might automatically mount it to a directory like cha-media, your username, USB drive. All the files and folders on that USB drive will then appear inside that directory, ready for you to use. The command mount, chadev, chetsdbone, chatsmnt, chatsdata, is a manual way to do this, attaching the device sdbone to the mnt data folder. Within any file system, you will primarily interact with three basic types of objects: files, directories, and symbolic links. A file is a container for data, such as a text document, a picture, a song, or a program. A directory, which you can think of as a folder, is a special type of file that holds a list of other files and directories. This is what allows you to create a nested hierarchical structure to organize your data. This organization makes it much easier to find and manage your information, rather than having thousands of files all jumbled together in one place. A symbolic link, also called a symlink, acts as a shortcut or a pointer to another file or directory. It is a small file that simply contains the path to the target object. When you try to access the link, the system automatically redirects you to the actual file or directory it points to. This is incredibly useful for creating convenient shortcuts to deeply nested files, or for allowing a program to find a critical file in a different location. You can create one easily with a command like ln-s path to original file.txt path to link. Getting permissions right keeps your data safe from prying eyes and prevents accidental changes that could break your system. If you don't understand permissions, you might leave documents unlocked or accidentally lock yourself out of your own work. Guessing is risky. Learning the logic is simple and empowering. Section 3. Who can do what? Understanding permissions. Every file and directory in Linux has a set of permissions that control who is allowed to interact with it and how. These permissions are broken down into three simple actions: read, write, execute. The read permission, represented by an R, allows opening and viewing a file's contents, or listing a directory's contents. The write permission, represented by a W, allows modifying a file, changing a file, deleting a file. For a directory, write permission lets you create files, delete files, rename files. The execute permission, represented by an X, is the last of the three basic permissions. For a file, execute permission lets you run it as a program, or run it as a script. For a directory, execute permission means you can enter the directory and access the files and subdirectories inside it. You cannot read a file inside a directory unless you have execute permission on that directory, even if you have read permission on the file. These three permissions, read, write, and execute, are assigned to three categories of users. The first category is the owner, the user who created the file. The owner typically has the most control. The second category is the group. A group is a collection of users, given shared access to a file. This is useful for teams, letting everyone in the group modify shared files. The final category is others. Every other user on the system, not the owner, or in the group. You can view permissions with a cons, dans notens, L. This command lists files in long format with detailed info. Example output. rwwzsvr 1 SAM project 4096 may set the report to common that the common verstidens, is the permission string. The first character shows file type, file, D, directory. The next 9 characters are the permissions for the owner, RWX, the group, RW, and others, R, always in that order. Once you understand how to read permissions, the next step is learning how to change them. The primary command for this task is chmod, which stands for change mode. You can use chmod in 2 different ways, symbolic mode, numeric mode. Symbolic mode is often easier for beginners because it is more descriptive. Who, U for user / owner, G for group, O for others. What, plus to add, minus to remove. Which, R, W, X. For example, hmodu plus x myscript.sh adds execute permission for the user. Similarly, chmod g-w shared file.txt removes write permission from the group. In this mode, read is 4, write is 2, execute is 1, 4, 2, 1. Examples: 7 aux rwx, 6 author rw, 5 aux rx, 4 off author r. To set permissions, you add the numbers you want for owner, group, others. For example, 4 plus 2 plus 1 equals 7. 4 plus 1 equals 5. 4 means read only. A dash or no permission is 0. Then combine 3 numbers for owner, group, and others in that order. A very common setting for executables and directories is chmod 755. Owner gets 7, read, write, execute. Group and others get 5, read and execute. The command would be chmod 755 my program. For regular data files, a common setting is chmod 644. This gives the owner 6, read and write. The group and others get 4, read only. The command would be chmod 644 document.txt. Sometimes you need to change not the permissions but who owns the file. For this, Linux provides 2 simple commands: chown, change owner, and chgrp, change group. To make a user named Jane the new owner of a file, you would use chown jane old file.txt. To change the group to editors, use chgrp editors old file.txt. You can also do both at the same time with chown by separating owner and group with a colon. Chown jane editors old file.txt. On every Linux system there is a special user account named root. The root user is also known as the super user. It has unlimited power. The root account can access, modify, delete any file on the entire system. This level of access is necessary for system-wide administrative tasks. Installing software, updating the system, changing ownership of files you don't own. Because this power is absolute, it's dangerous to use root for everyday tasks. A simple mistake could severely damage the OS. Use sudo to perform admin tasks safely without logging in as root. Sudo stands for super user do. Place sudo before a command to run it with root privileges. Example: you cannot normally change the owner of a file you don't own, but sudo chown bob important system file will do it. The system will typically ask for your password to confirm authorization. Always think twice before running sudo. Let's review with examples. L to see permissions. chmod u+x myscript.sh to make your script executable. chmod 1664 shared doc.txt to let group edit and others read. Sudo chown ralex.developers home project folder to hand over ownership recursively. The R flag applies changes to all files and subdirectories. Understand these pieces. File systems permissions, RWX, ownership owner group, others, LS, chmod chown sudo, that removes the guesswork from file management. You can now diagnose permission errors and set correct access. This keeps your data secure, your scripts running, and makes collaboration easier. Linux permissions are a logical system you can learn to control who can read, write, and execute your files. For hands-on help, contact US Computer Support.